Bismillahirrahmanirrahim. Dear students, let's discuss the solution of B section's assignment, and for that purpose I have selected this assignment. The problem number 1 has a cantilever beam and a point moment is acting at the free end. Magnitude of the movement is 8 kilonewton meter. It's a simple problem. We have only one, we will have to consider only one portion in one section. The magnitude of the resultant acting in the vertical direction will be equal to 0, no horizontal reaction, and there will be just one resisting moment. RA is 0 and M is equal to minus 8 kilonewton meter, because in this assignment in the reaction the direction of reaction movement is in clockwise direction. The applied movement is also in clockwise direction. That's why this one came out to be negative. When the reaction comes out to be negative, there are two approaches. Approach number 1 is for the solution onwards, you change the direction of the reaction, whether it's a force or a movement, and then take that reaction as positive. Other approach is that you keep the direction as it is, but you consider a negative sign with that. I personally prefer the first approach, but even if you follow the second one, that is also fine. But you will have to be careful in every case then that you consider the sign of the of the reaction. So here are the equations for shear and bending moment. Now if I look at the final diagram, the final diagram appears fine to me. The shear force is 0 and the bending moment has a constant value throughout the span with a negative sign, minus 8 kilonewton meter. So this seems fine. The elastic curve, it's also fine. The only observation is that in this case the elastic curve is straight for most part of the beam, and I would suggest this is probably not very appropriate. If I draw this, I'll draw it something like that, or no, I think even this is a bit more, something like that. Means some initial portion, and when you draw it, do not give a sharp bend at this location. So this is the problem number 1. Now the second problem has multiple couples, and after every couple before and after every couple we will divide the beam into a portion. So this beam has multiple portions. The point should be A, B is here, so C, D, E, F. In this solution, the sections have been labeled as C, D, E, F and G. I prefer to label the portions, but anyways this doesn't make much difference. So there will be 1, 2, 3, 4, 5 sections that we'll have to consider. The reactions have been calculated. These reactions seems okay. Now let's see the final diagram. Because there are multiple portions, I do not want to go through each one of them. Let's jump to the diagram and see whether the diagram is closing or not. So we have shear force constant, so this seems okay, and the bending moment, and we can see that we have multiple point movements. So having two values of movement at these locations is logical. So we have 0.86 here and 5.86 here, because this movement is positive and it's in clockwise direction, which means positive. So a jump of positive 5 is fine. And then we have 6.29 here, then this is 6 and this negative, so in the downward direction this is also fine. 0.76. okay, if this is 0.76 and if this is correct, this should be 8.76 or this should be 0.71, because the difference should be equal to the magnitude of the couple acting. this is 8, so this distance should be exactly 8. But the bending moment diagram is finally closing, which means that overall the diagram is fine, and we have positive bending moment for most of the part, and we have negative bending moment for the last part. So for the positive part, the elastic curve will be sagging, as it is sagging here, and for the negative part it will be hogging. It is drawn correctly, but I would suggest that when you draw, try to make this transition smoother. It's hard to draw a smooth line using the mouse, and plus this line is pretty thick, but when you draw it with a pencil, thin pencil, try to make as smooth transition as possible from sagging to hogging and vice versa, because if no internal hinge is present, there will be no sharp bend in the beam. This transition will always be smooth. Okay, rest of the solution seems fine. Then we have an overhanging beam subjected to a point load at the extreme end in the upward direction. There will be two reactions, RA and RB, and we will consider two portions. We can label this point as A, this point is B, and this point is C. We have reaction calculations, and then we have two portions, AB and BC. Let me see the final solution, the diagram. So for this part, the diagram is positive, then we have a jump of 10 and then 6. So the shear force diagram seems okay. The bending moment diagram should be first degree. It should be 0 at this external hinge support, and it should be 0 at the free end because there is no point moment acting. And one noticeable point here is that it's a roller support, but still we have some value of moment at the roller support. And this is possible because this roller support is no longer an external roller support. We have some part of the beam present on the right side of this roller support. The moment on external roller support is always equal to 0 if there is no externally applied moment on that, but the presence of this overhang makes it like an internal support. But on this side we have a hinge support, and this is an external hinge support, so we have 0 bending moment, and that is totally fine. So this solution, the diagram is finally closing, first degree lines. So this solution seems fine. The entire bending moment diagram is positive, so the elastic curve should be sagging like this. This is rightly drawn here. Okay, now the next problem, in this simply supported beam case, we have two UDLs. One is acting in the downward direction, other is acting in the upward direction, and their intensities, I think both are 5 kilonewton per meter, and in this case we will have to divide the beam into two portions from A to this point. We have labeled it as C here, and then from C to B. Now let's see how does the shear force diagram and bending moment diagram look like. There is an upward reaction here, then the shear force comes down and then it goes up. The value is equal to the value of reaction, so the shear force diagram appears fine. We have 2 points with 0 shear, so at these 2 points we should calculate the magnitude of bending moment. First we need to calculate the location of these points, and there are two ways to calculate the location of these two 0 shear points. First way is we can consider similar triangles, so you can consider this triangle and this triangle, and second way is that you can put the equation of shear force for portion AC equal to 0, and that will give you the location of X. Similarly for portion CB, you can put the equation of shear equal to 0, and that will give you the location of X, means the location of this point with respect to the extreme left end of the beam, because we always mark X in this way. Then we have the bending moment diagram. We have a peak at the zero shear point, so it seems okay. These are second degree lines, and the slope of shear force is the magnitude of shear force is decreasing, so the slope of bending moment diagram is decreasing. Then this is also fine, and this part also seems fine. This bend should not be there. It should be as smooth as possible. Okay, and then second degree, so this seems fine. We have partly positive bending moment diagram and partly negative. So in the positive part we'll have a sag, and in the negative part we have hog. That is rightly drawn. The only thing is that this transition should be as smooth as possible. So this transition from sagging to hogging should be as smooth as possible, something like this. Try to avoid this sharp end. Okay, so this was the fourth problem, and the fifth problem, we have a simply supported beam which is subjected to a point movement. The reactions will be equal in magnitude and opposite direction, minus m over L plus m over L, so that seems fine. Then we just need to consider two portions. Let me see the diagram, bending moment diagram and shear force diagram. Shear force diagram is okay, which reaction was positive and which one was negative? Let me see. The reaction at support A is positive and at B is negative. So at A is going upward and B is coming downward. This is fine. Shear force diagram is correct. The bending moment diagram also seems correct because we have a negative movement. So we go up to plus m by 2, and then we come back to minus m by 2. Movement at external hinges and hinge and roller support are equal to 0. So this part should be sagging and this part should be hogging. Sagging and hogging are rightly marked. The observation again here is that this transition should be as smooth as possible. And this problem number 6 is same as that of section A, and I have discussed that in the section A's video, so I will not repeat that here. So that's all about section B's assignment. Thank you very much.